Hello YouTube, this is my C++ Minecraft clone, and we'll start with the summaries for everybody that is clicking here for the first time. We'll do a summary, then chat will decide what we're going to do today, and at the end of the stream I'll do a summary which what happened this stream, which will be in about 3 hours. So let's do a summary, because last 2 days there was no stream. In the very last stream, we attempted to add creepers, but we didn't manage to do the pathfinding. So we are able to summon creepers by doing here summon creeper like this. Yo, what's up, Alex? This is what we managed to do the last stream. We managed to summon creepers, and we had like this command. And here, even when we press up, we get the previous command like this. So we have the creepers. Also, like, we have chat here. Hello. Hi chat. We have a chat that disappears after 5 seconds. And we have the village. This is our village, which is very simple. It just has this center here, the fountain, and from here you get all of the roads. To the left and right there's a chance of a house spawning, which are just placeholder houses. Here we have like terrain generation, we have the trees, we have animations, TNT, we have clouds, and here the TNTs. You can destroy them, they explode like this. They lag a bit, but they actually work. The TNTs actually work. And here we have like animations, fire animations. Fire animations. So chat, did you miss stream? What's up, chat? Did you miss stream? Anything else? Better caves? Yeah, we also have the caves. We also have caves. Anything else that we're missing, chat? As a summary, yeah, we have fluids as well. We have fluids, but they don't have like physics. They don't have physics. Here we have fluids. The water is a bit transparent. Yeah, we also got cake, but we have Frustum Kalink as well. Oh yeah, crafting, yeah. We have Frustum Kalink as well, which is not like fully implemented, and it's not like perfect. But we have Frustum Kalink, which like doubles the FPS. And we have a crafting table, which we can right click. Here we can right click crafting table, and we can put a few stuff here. Yo, Coconut, thank you for following on Twitch. We have crafting table, and also we did 3 streams where we added multiplayer. And the multiplayer, we managed to first create a chat system where 2 clients interact with each other using a server. And then the other stream, the 3rd stream, we managed to like link to connect this game with the server, where we started getting the terrain generation from the server. That's when we attempted to do multiplayer. Yes, so I think that's kind of the summary. So the last thing is we attempted to do the creeper here. The last thing is we attempted to add the creeper. That's the last thing. Anything else, chat? Yeah, we have pistons, we have the portal. Yeah, pistons interact with the torch. They interact with the torch. And we have portal, which has animations. Oh, also we have particles. We have these particles. We have these particles which change the texture depending on which block you're destroying. And the particles we implemented in 3 hours. They look weird, but we had a limit of 3 hours. If we add more 3 hours to it, we can do them better, but we just speed run them in 3 hours without knowing how to implement particles. Bro, it's all right, man. It's all right. Yeah. Oh, thank you guys for following on Twitch. Okay, so that's the summary. That's the summary for everybody that has seen this project for the first time. That's the summary so far. And so now, like usual, we'll start to brainstorm idea. We'll pick an idea, chat will pick an idea for what we're going to do today. Like every time, chat will get to decide what we're going to do. And here in the notepad, we gather a few ideas. Here in the notepad, like this. Sure, and here we gather a few ideas and then we need to pick from one of them. So here, minecarts. Yo, Jake! What's up? I missed you, Jake. What's up, Jake? Minecarts. Bolts. The nether. Modding support. Multiplayer. Sounds. Third person. Hold item. Better caves. What else, chat? What else can we do today? The end. Yo, Immortal. What's up, Immortal? The end. We could also do the Ender Dragon. Health and hunger system. In modding made that you can code in other C++ files. The mod, use it in your clone. Anything else? Food? Yeah, that's in the health and hunger system. Anything else, chat? Yeah, I'll bring from the previous streams ideas. Just for inspiration. Yeah, the spear. Okay. The spear. Command blocks. Animals. To finish the creeper. Mobs. Sulfur cube. Anything else, chat? Doors. More biomes. That's good. That's good. Desert structure. Desert structure. Weather. The weather. Weather system. Item drop. Thank you. Elytra. Last time Elytra almost won. That was last time ago. It almost won. Fireworks. Fireworks. Shaders. Settings. Anything else, chat? Finish particles. Anything else? Do you have different type of villagers? Villagers. Better villages. Better villages. Fishing. Swimming. Yeah, swimming. Pathfinding, that's for when we finish the creeper option. That's the finish the creeper option. FOV change setting, that's for the settings option. We have already covered it. Block break particle, make the full texture particle in Minecraft. Yeah, but we didn't have time for that. And we'll improve it in finish particle if chat picks that option. Ores a good idea. That's a good idea. Armor. Oh yeah, the weapons. Weapons and tools. Weapons and tools. Farming. Do we have farming as an option? Farming. What about shaders? Not vertex fragment, but stuff like... We have it as an option. 26 option. Trading. Make... Editable things like a new update. The cushions, you mean? The cushions. Make... This can be possible in JavaScript multiplayer. We have that as an option. Dimitri, it should be from your connection, the luck. We could try Godot with C++, that's interesting. Try Box 3D Physics, that's interesting as well. Mobile support, not a good idea. Modding is cool, but modding is cool, but it's another 100-part episode. I like Hell because it's a big step towards being playable. I'm not that interested. Like, it's fine if it's not playable. My Java clone is already playable. Jake, it's fine. I don't crave making it playable. Chest and hopper. Chest. Hopper. Controller support. How complete is it? A percentage? 0.1%. Like, literally, I'm not even joking. Liquids have physics. Lua modding. Oh, imagine if we have Lua modding. The game menu. I think we had the menu as an option. Menu? No. Menu. Game menu. We have music as an option. Jolt physics. Jolt physics. Anything else, chat? Gold meshing, greedy. We're not doing greedy meshing. Minecraft, which can be attached day-night cycle. Oh yeah. 3D clouds. Like improve clouds. Like finish clouds. Because they're not finished. Anything else? Command blocks, we have them as an option. Command. Yeah, command blocks. We have it as an option. Spear combat, we have spear. Horses. Horses, the dog and cat. There are ideas that are not in only in official Minecraft. Only in the official Minecraft. Fire spreading. What's backface culling? Skeleton. Skeleton. In village. Better villages. Yeah, we have villages as an option. Anything else? Armor. Cat. Warden. Lakes. Performance settings. What do you mean by that? Mesh and all the faces that can... Oh, so you mean custom culling? We have custom culling. Like, we could improve it. Improve, like, finish custom culling. There is no greedy meshing in Minecraft. Can you implement a way to disable every extra effect? Pay to win. Graphic settings. We have settings as an option. We have shaders as an option. Potions. Potions. Game modes. Game modes. Better inventory. Better crafting. Anything else? There should be easy because you can look at the GLSL from something like... No, they use different stuff for the shaders. They have their own specification for shaders. They do differently PBR shaders. Minecraft uses greedy... Minecraft doesn't use greedy meshing, bro. Player kicking and banning for multiplayer. We don't have multiplayer. Entity component system. What do you mean by that? Placeable pumpkin. The trident. Sure, that's a good idea. That's a good idea. Anything else, chat? The pick. 3D noise gen. 3D noise world generation. I'd like to... We attempted 3D noise, but we failed. We can try again. If viewers want it. We can try again. Yeah, we have the Elytra as an option. Camera view Bob for 3 hours is too much time. Or anything else? The hand. I think this is covered in to hold an item hold. To hold an item. We'll do the hand there as well. Yeah, okay. Here, item hold and the hand. Let's do that. Where is that? Item, yeah, hold an item and a hand. Anything else, chat? Third person view. We have that as an option. We have that as an option. Let's do one more option and we'll do voting. One more option. Iron Golem. Iron Golem, that's a good one. Iron Golem. Yeah, we have another one. Fish. Okay, we'll add hero brand, but I don't know what to do in that case. I had an idea, but I forgot it. It doesn't matter, Jake. You can try to remember it tomorrow. Okay, okay. Let me do a poll, chat. Let me do a poll. Let me do a poll. But I first need to create the poll, chat. You need to wait a second. I need to create the poll, chat. Give me a minute, chat. Give me a minute. I know everybody likes voting here. This is everybody's favorite part. To vote what to do. But a lot of people will get disappointed. What to do today? Okay, chat, I need 4 options, chat. And don't repeat them because you'll get banned. So we got 4 2 times. We got 4 from different people. We get 38. And post numbers, guys. Post just numbers. Don't just post the numbers. Vote 5 and here another 5. Okay, we got 4 and 5. Oh, we got 42. We got 42. 4. 42. 50. 67. 38. I think I saw 38 somewhere. Yeah, 38 for Kraken. And who else said 38? Again, Kraken. Bro, I'll ban you, man. Oh, 1. Somebody else said 1 as well. Somebody else said 1. Yeah, Jake and you. Okay, 1. Okay, we start the poll. Okay, we started the poll, chat. We started the poll. So now chat is going to vote what we're going to do. There should be a poll that starts and we'll see what the options are. So the options for today are modding support, multiplayer, and 42 is liquid scar physics. That's a good one. That's a good one. And number 1 is minecarts. Okay, okay. Yeah. That's a good option. Okay, and we'll wait around like 5 minutes just to be sure. We'll wait just 5 minutes just to be sure. We'll wait 5 minutes, chat. So the options are like, and we'll give it 3 hours. We have just 3 hours, chat. Whatever you pick, we'll give it 3 hours of time. And whatever option you guys pick, first we'll need to open Minecraft and look at Minecraft for reference just to see how we're going to attempt to do it. And after we figure out a plan for implementing it, then we'll set goals and try to achieve those goals. And hopefully by the end of 3 hours we have pretty good implementation. But just so you know, guys, it will not be perfect. It will not be perfect. I'll do my best. I'll do my best, chat. Like every stream. So we're voting right now on number. We need to pick between these 4 options. The first option is number 4, which is modding support. I have no idea how to do modding support. The next option is number 5, multiplayer. We attempted to do multiplayer 3 times. we managed to get from a server the, what was it? The terrain generation. We managed to generate the terrain from the server and send the data to the client. That was interesting. But we stopped at that point. And 42 is liquids and physics. Like liquids to have physics. That's an option because we only have like water and lava, but they are like solid blocks. They don't flow around. They don't float around. That's a good option actually, because I've never done that. And number 1 is minecarts, which is also fun actually, because we have rails. Okay, we'll end it at 3 minutes because it looks like 42 will win. We'll end it at 3 minutes. Well, guys, my cat is here. Let me see my cat for a minute. Okay, I'm back chat. After like this says here 3 minutes, we'll end the poll and we'll do probably option 42. Okay, 3 minutes. Chat, we're ending it. Chat. In 3, 2, 1, ending it. We're ending it. Okay, so chat voted for what we're going to do today, and they picked with 50% option 42. And option 42 is liquids have physics. Okay, chat. That's a very good option. And as I promised, let's open Minecraft for reference. Let's open Minecraft here. So last time we attempted to do the creeper, which we couldn't manage to do the pathfinding. But it's fine. Some other time we'll do it. But now chat voted for liquids to have physics. And I have the lava and I have the water. They need to have physics. They need to float down. So let's open Minecraft as reference. Let's open Minecraft. And let's see the physics of the liquids. So here let's get some water and some lava. Lava. Is there a difference between the water and the lava in their physics? That's interesting to see. Let's check them out. Let's try to spread them in a flat terrain here. Here it's kind of flat and see what happens. So this is the water. Interesting. Okay, and let's put some lava and see what happens. So this is the lava. It's a lot slower. Sure. Lava moves slower and water can be spread infinitely. Liquids flowing tend to be wedge shape, slowly getting smaller and smaller until there's no more of liquid mass of it. Okay, so this is the lava. So this is the difference. They have different speed of spreading, and the lava, as it looks like, it's spreading not that further. So it's fine. If we do one of them, we'll have both of them. It's fine. So they're quite similar, at least in the mesh. And so here is how they look like. They're a lot different from the other blocks, because every block, usually here in Blockbench, like this is the program I use to look at assets. This is the program, and here no matter which asset we load, it's always some kind of a cube. Always. Even if it's like the anvil. Let's look at the anvil. Just to show you guys. Anvil. Here the anvil. Look at this, chat. Even this complicated shape, it's made out of cubes. Here is the anvil top. This is the cube, but it's like stretched a bit. And then the next section, this is again a cube, which is like a different size. And the other part. So every shape is out of blocks. Like every shape is made out of blocks. And here, for the first time, it's different. Here it's different. Even the grass, look at the grass. You could say, okay, the grass is different. No, it's not. Even the grass is the same. Even the grass is made out of cubes. And I'll show you what I mean. Let's open the grass. Short grass. Let's open the grass. Here, this is the grass. And here we have 2 cubes again, 2 cubes. And it's just like squished. The cube is squished. We can increase its size here, the z-axis. Look at this. It's a cube. Even the grass is a cube. Even the grass. So this is the different part, the lava. For the first time, we'll be creating a different mesh than the blocks. This will be the most difficult part in these 3 hours. Fun fact, lava is spreading twice shorter than water, but it only works in the overworld and break the block under the lava. Please hide from your channel. Oh, wait, what happened? Who should I hide? One second, guys, I need to go back in chat. I don't know what happened. I cannot find this person. Maybe Mortal has banned him. Like, who is this person? I don't see anything, chat. I don't see any. Yeah, I didn't see anything. Bro, I'm going to hide you, man. Like, I don't see anything. Maybe Immortal Dev Automod. Oh, okay. Automod. Yeah, okay, 10 guys. Okay. So it's fine. So here for the mesh, we need to figure out how are we going to handle this. We need to see how we're going to handle this. Break the block under the lava. Okay, we'll just place it here and break this block, and so it goes down. Oh, we can more easily look at it. Yo, Here it's like a cube. Here it's fine, but here it goes down a bit. It for sure it's not a cube. For sure it's not a cube. Okay. I had an idea. Where we could just focus first on the spreading of the water and lava by using simpler mesh, by just like the snow layer, like this. To start with this, just so it goes down, just so we have some kind of liquid, be a simpler mesh, and from here to make this look like this. So here it will be like this, and here like this, maybe, yeah, something like this. And then we'll improve the mesh to connect from here to here. That's what we'll do, chat. That's my idea. Obviously, water uses pathfinding that checks the minimum distance and flow. Let's say time set day. And what about the water? Yeah, here this will be like this. It will be one layer. Here it will be one layer, but somewhere here will be like two layers, and then we'll connect them together to be smoother. So it's basically just this, but smooth. It's a lot smoother. We can start with this and make it a lot smoother. It's a lot easier to start, much simpler. So anything else, chat? Anything else that we need to cover? Yeah, here it will start like this. Can it go even more high? Yes. Yo, it can get a lot more higher. Yeah, we'll start like this and we'll focus on the spreading part. After we have the spreading part, we'll make it look better, just like here, the lava. That's the idea. That's the idea, chat. That's the idea. And then we'll add the textures, the water texture and the lava texture. And then we improve the mesh and that would be it. I think it's possible to have some kind of implementation in 3 hours. I think it's possible. Let me go back to the Minecraft clone. So here is my clone. And we already have here the snow layer. We already have the snow layer, like this. We already have it. We'll reuse its mesh for the liquids. We'll reuse its mesh. And we already have like the texture and they're already animated. So we're pretty close. And we're pretty close, chat. Are the liquids still technically cubes? In a simplified matter, you can need to change the height of the... Yeah, like, it's fine, it's fine, it's fine. So chat, is this the idea that we're going to do? Is this what we're going to do, chat? To make the mesh simpler, like just cubes temporarily, like the snow layer, so that we can focus on the flow. So for example here, the logic, the water to spread to here. What happens when the water spreads from here to down here? What happens with the mesh? I want to see how the mesh looks like. Like this. So here, down here, it's a full block. And up here, it's like how much? How much is up here? Up here can be 2 layers. Yeah. Above it, it will be 2 layers. And here it will be, when we place it, how much is this? This is, does it say the layers? Where does it say? 6 layers. This is 6 layers. It can go more, 2 more layers. Okay. So when we place water, it will be 6 layers. And when it spreads like here, it will be like, how much is this? This is 2 layers. Here it's 2 layers. Sure. And here it's like full. Here it's like a full block. Here it's a full block. And at the end it will be 1 layer. Okay, let's do this, chat. Let's do this. Should be simple, chat. Should be simple. After we do it with these simple shapes, we'll improve the mesh. But let's try to... let's see if we need to make any commits. Summon creeper or attempt. We did an attempt for creeper pathfinding. We did an attempt. Let's commit that and push it so that we can focus on the liquid physics. So let's see, chat. What's the idea here? What's the idea? Where's the water? Yeah, let me open back the game again, just so we decide how we're going to handle this. So here is the water, and we place the water. Sure. We place the water. What should happen? It should spread like this. It should spread. Okay, we'll make it spread. And here it will be lower. Here it will be lower. It will be lower. And here again it spreads more, until it's like 1 layer. Until it's like 1 layer. And then the spreading stops. Anything else? Okay, so when does this logic need to happen? On placement, I think. Yeah, let's just do it on placement. When we place water, let's make it go to its neighbor with a lower layer, like a lower mesh. Yeah, let's do that. Until it reaches like, okay, so does it have currently a block state, the water? Does the water have block state? That's what I need to know. So where are all the block states? We need to go in block header file. And we need to find water. Okay, we have the water, sure. Does it have any? So it should have a block state. Let's find the water JSON file. Water, here it is. Okay, so it has a state of how many layers it has. By default, it's just 8. Okay, so it's fine. It's fine. We are already pretty close to having some kind of simple physics. We're very close. We have the rendering, we have the block state, we just need to spread it on placement. Okay, let's focus on that. So here on the water, let's do on placement callback. Here on placement. When we place water, to decide what we're going to do. Yo, Nox, what's up? You're back finally. You missed stream, Nox? Okay, so water on placement. How are we going to handle this? Water on placement. We need to go to the neighbors. Let's just go to the direct neighbors. Okay, let's do that. Let's keep it simple. Let's go to the direct neighbors and spawn water with a lower layer. Let's do that. So let's get the neighbors. So here we need position details. Let's get the north. Like here, neighbor. Let's get the north neighbor. Let's get the south. Let's get the east. And let's get the west neighbor. The west neighbor. And for all of these, let's spawn the water again. Okay, so let's just focus on that. Let's just spawn the water and then we'll change the layers. Today's topic, we're doing liquid physics. Yeah, what was exactly the option? It was, yeah, liquids have physics. I can change the stream title. Okay, I'll add liquids physics as the new title. I updated the title on where is chat. Here is chat. Yeah, okay. So how are we going to change the neighbor to be of type water? And let's do neighbor set block type to water. Let's do that. Like that. And here, okay. So now when we place water, its neighbors will be also water. Let's see if we get that. And they will be the same layer. They will be the same layer. Here was the issue. Let's restart it, just to be sure it's not something insignificant. Let's see the call stack. What did we break? We broke something. What did we break? Here, block. This is some kind of a constructor. Sure. Where is it being called? Water that has under 8 layers should not be breakable and requires a water block. Do you know how can I link library C++? Just use CMake. What happened with the Visual Studio, man? Bro, the Visual Studio stopped. Okay, let's start again, but this time in debug. Just so we can catch the error. Whatever the error is. What code did we add actually? Yeah, just placement. We didn't add something that difficult. Yeah, it's the same error. The same error. Get block here. So here, getting the water. What's actually the error? I didn't see. Stack overflow. Oh, I get it, chat, I get it. Yeah. Stack overflow. That's because when you call a function name, we are adding data to the stack. And the stack is very limited. It's not like the heap. The stack is where you save information when you call functions. Because when you call a function, it needs to store like the parameters, variables, function name, etc. And we're recursively calling the same function probably. That's why we get the stack overflow. See chat reference here. Stack overflow. Here, the website. You know, Stack Overflow? Stack Overflow mentioned. Are you using graphics API for this project? I'm using C Raylib, which uses OpenGL. So where is the code we called? We called it here on placement. Yeah, here set block type. We set block type here. And here we call on placement. That's the issue. We call on placement here, which calls it again and again here in the water. In the water, set blocks and calls, yeah, we're recursively calling the same function. So how are we going to solve this? How are we going to set a block type without calling the on placement callback? How are we going to solve this? Yeah, because it will recursively spread infinitely. Here the water will spread infinitely. Yeah, that's the issue. It will spread infinitely. Okay, so when spreading, okay, so let's target the layers. So let's, from here, let's spawn it with a layer of like lower layer, so the water to go down and to stop at some point. That's how we'll stop the recursive part. And how are we going to do it from here, actually? How are we going to do it from here? Because once we do call this, it will call this, and it will call this, and it will call this, and it will call this. So we need to do it before here, even before here. Do we have another option then? Do we have another option? Yeah, here, let's... do we have another option? Do we have another option? That's what I'm thinking. That doesn't call this. Yeah, here we have set block type with just this. So, and here we don't call the on placement. Here we don't call it. We can temporarily remove it just to see what's up. Yeah, let's temporarily remove it. It's fine. It's fine. Let's temporarily remove it. So now when we place water, I'm expecting to... oh, we are in debug mode, yeah. I'm expecting to get the neighbors to be also water. The direct neighbors. Let's spawn water. Okay, look at this chat. Now when we spawn water, it spreads to the direct neighbors. It looks kind of weird, chat. Let's screenshot this. So we can update the thumbnail. And we'll proceed further. Screenshot this. Okay, I updated the thumbnail. Where is chat? Here is chat. Okay. So we managed to make it spread. So now let's make it like go lower level. We needed to go a bit lower than this every time it spreads. So let's first do that when it spreads to make it be on a lower level, and then we'll make it spread even more, and then we'll probably make it like here to go down. Here to go down, so it continues to spread. Once we have this, then we'll improve the mesh as well. Okay, let's do that, chat. Let's do that. So how are we going to update the block state? How are we going to do that? Because I need here for when we set the block type to be water, I also need to change it to be at a certain level. Maybe, actually, let's make a custom function, probably. Make a custom function temporarily. Because we need logic for all of the... no, actually, let me think about this spreading algorithm. It can be an algorithm, actually. It can be like, we can use like the BFS traversal, breadth first search we can do. Here we can do a quick queue data structure. Where we input the nodes will be the position details, because we need to spread it. We need to spread the water, and yeah, okay, let's do the actual spreading here. Let's do the actual spreading. Yeah, thank you guys here for like sending some stuff. I don't know what these jewels are, but thank you guys. I don't know what the... and I don't get a notification for them. I don't get a notification for that stuff. But I appreciate it. Make function called onTick update on something. We don't need onTick update. Here we need a breadth first search. Here. And how are we going to do it? We need a queue. We need a queue of position details, like this. And let's rename it like BFSQ. Let's rename it, and let me think about it. Let's remove these ones. We don't need them. And let me think about it. And here we need it to spread. We need the water to spread here. And let's do, and here in the BFS queue, in the queue, let's push the current position. The current position. Let's push it. And here let's do while it's not empty. While it's not empty. And here, let's get the current node. Position details. Here front maybe. And we need to pop it. This removes the item from the queue because we need the queue to lower. And so now we're traversing in a breadth first search style. The alternative is depth first search, but here we need breadth first search. What are we going to do every time we cycle? We need to get the neighbors and we need to get the current block. And how are we going to do it? Here we need, this is the current position. This is the current position. We need, what do we need? We need to set the block type. We need to set the block type. Here, let's do, here in position details. How do I set block type? Where is it? Where is set block type? Set block type here. Let's copy this temporarily. Here, let's paste it here because we need some custom logic. And here we need, this will be the node subchunk origin. And here we have the subchunk reference. Here we want just to set the block type. And here we want, what do we need? Subchunk position to index. And here we want the local position. Local block position. We need to set the type to water for all of them. But we need the current level, water level. Make water block have a state for flow direction and water level. Oh yeah, we need a flow direction, which doesn't load because of, yeah, chat. Yeah, we are doing it too simple. Because look at here, how water doesn't spread to here and here. It just goes down here. Oh, a direction. A direction. Oh, I didn't think of this. I didn't think of this. Oh, there's no pink in the Discord. Is there a pink? Let me do. Oh, there's a pink. You debated me. How are we going to spread the water? Oh, let's keep it simple, chat. We don't need direction. Like here, somebody said to have direction, and he's right. Chat is right, because here, look at how it doesn't spread everywhere. Here it just goes down to this block. But it's fine, let's keep it simple. Let's do a breadth first search, and then we'll decide on a flow direction. Flow direction can be calculated by looking at adjacent blocks you're flowing in the direction where the block heights are lower. Oh, so if I place the water up here, oh, and it goes from here to down here. Oh, you're right. Bro, this water is infinite. It's infinite. When does this water actually stop? Look at this spreading, man. Bro, look at it. This was just one bucket. Bro, how much water is in a bucket? So how are we going to tackle this? Chat, this is the goal. Like, this is the goal. Chat, let's keep it simple. We don't need to make this like infinite water. Let's keep it simple. Let's keep it like here when there is no like direction. Like this. We'll do this thing. This is what we're going to do. Yeah, this is what we're going to do. We don't need it to be so infinite. Yeah, let's keep it simple. Yeah, okay. Okay. So we go over the neighbors and we set the type to be water, but we need to keep track of the current layer. we need to keep track of the current layer. Here, let's do an integer current level, water level, let's say. Water level, and how many levels do we have? How many levels do we have? Let's look at the water. We have a height of 0, height of 2, 4, 6, 8, 10, 12, 14, and probably like a full block as well. So current level, what's the maximum? What's the maximum? What's the maximum? It's like 16 maybe. Yeah, let's do 16 as a maximum. Let's start with the current level of 16 and we'll go down by 2. We'll go down by 2 every time. Here we start by having it be 16. And what else, chat? What else, chat? Let me think about it. We can do this infinite water thing with just the conditional loop. If the block below is air or not. The Minecraft wiki has good information on water mechanics. Yeah, but that's for more complicated stuff. Water Minecraft wiki. It's fine, chat. This wiki will need it a bit later, not right now. Right now we're doing much simpler stuff. Water spreading. But let's just do a quick peek. Yo, flow arrangement. Yeah, from 0 and like this. Okay, it's fine. Height in blocks. Yo, this is probably helpful. Yo, what's this? Click to interact. Press play to spread source. Where is play? What's this? Play. Keep safe rendering speed. Play. Yo, here water is spreading. Here is some kind of a mini game probably. Interesting. Yeah, this is helpful, but not right now. Yeah, okay, so we'll attempt to implement the water, but give me 2 minutes, chat. I'll be right back. I'm back, chat. Every time water spawns, if the height of the water is greater than 1, look at the neighbor, see if it's air spawn. Bro, that's too complicated, Jake. Value between its own height. So water with height 2 doesn't make internet water height. No, Jake, you are thinking too far in the future. Determined by vertex height. No, it's fine, guys. It's fine. Let's do it simple. Like, let's do a simple water spread, and then we'll add the other stuff. Let's keep it simple. We're still at the beginning. Here, this is when we place the water. We're trying to spread it. Just came back from a week-long vacation. What did I miss? A couple of things. Yeah, chat. Let's do the very simple spreading. Let's make the simple. Here, we just go to the direct neighbors. The north, east, west, and south. We do it very simple. And so here, we spread the water. But let me think about it, chat. We need to know what the current level is. What's the default? Water. What's the default? So layer 8 is the default. 8 layers is the default. 8 layers. So here in this current node, if we get the current layer at the start, it will give us 8. And for the neighbors, what are we going to do with the neighbors? We spread to the neighboring blocks and we... Yeah, and we need to check if it's like block type aware. Yeah, okay, so let's get the current layer. Int current layer equals, we need the block state. We need the block state. And here let's do std shared pointer block state equals world get block state for the current node. And here what do we want? Chat? We want to get a property. We want block state get property. We want layer. We want the layer like this. We want the layer. And is it a float actually? Bro, what's the layer? Yeah, we want the... Oh. Yeah, we want it to be... What do we want it to be? Let me think about it. We need to spread the layer. We start from 8 and the next one, the neighbors will be, let's say, layer 7. And the neighbors will be layer 6. The other neighbors will be layer 5, etc. The layers will go down of the water up to like 0. And that's where the water stops. And we are doing a breadth first search, pathfinding to like initially spread it, the water. That's what we're doing. And like we added as a node the current position. When we place the water, that's the node we add. When we place the water, that's the node we add, and we go over its neighbors. And for each of the neighbors, we need to check if... let me think about it, chat. Let me think about it, chat. Yeah, what do we need to happen? We need... Okay, let's keep it simple. Let's temporarily hide this. We go over the neighbors and we set the neighbors to be water. We set the neighbors to be water and we will set their... and we need to set their layer to be like how much? Like -1, the current one, right? Yeah. So current block state, and here we have neighbor block state. But do we need to do it like that? Okay, let's do it differently. Okay, it's fine. We can do it differently. We can spread it from here actually. It's fine. We can create here structure. How should we call this structure? It's like it's a node. Sure, it's a node. Let's call it a node. And it needs to be position. It needs a position. And it needs current layer. Well, let's do it like that. And here and this needs to be a node. And here we push position details and with a layer of like 8, the default. And so how should we handle this? And here, this now is a node. This is a node. So this is the current water block. What do we need to do? This is the current one. Okay, we go over the neighbors. Let's go over the neighbors. Let's go over the neighbors. This is position details like this. Position details like this. Okay. And so what do... let me think about it, chat. Let me think about it. No. We're spreading the water. And here I was thinking to do like... we go over the neighbors for every node, and here to push in the BFS queue, push a new node. To push a new node of like... Oh, we need to get the neighbor actually. We need to get a neighbor. Yeah, let me think about it. Yeah, let's remove this actually. Let's remove this. Okay. So we go over all of the nodes. And we push the neighbors. Here we push the north neighbor with current layer -1. That's what we do. Chat. And then the other neighbors like this. And here this is the south, this is the east, and this is the west. That's how we spread the water. And here when we get this node, let's set just the position and the block state. Let's do that. So let's copy from... where was it? Here. Yeah, we need to bring back the code here. For every node, let's change the block type to be water. Let's do that. Here, node. Position details. Like this. And here subchunk. Position to index, we do node position details local block origin, and here water like this. And we need to set the block state as well. We need to set the block state, the layer. So here we do std shared pointer block state equals world get block state of the node position, and here we need get property layer, and here layer we need to change it to be like node current layer like this. We need to do it like this. And here what do we need to change here? How to access the property. Like value. How was it? Value. How was it? How to access it? Oh, this is a different layer. Yeah, that's different. We need from the properties. Namespace layer. The layer. We need like that. Something like that. We need references. We need definitely some references. Properties. Like get property. Here, this thing. Yeah, something like... Oh, so it's prop. It's just prop. And then value. Okay. Water here. So this should be just prop layer, and here value. What properties do we have? Do we have layer? Layers. It's layers, not layer. It's layers. We set the value to be the current layer. Okay, so now we should have water spreading. For the water models, we'll figure it out. We'll figure something out. Future me will figure it out, chat. What's the issue? Happened? Oh. Because we're spawning like oceans, we're probably getting the on placement. Let's remove that from the world generation. Let's go to the sub chunk. And sub chunk, where do we have like generate like block? Where do we have generate blocks? Here. And so what do we do here? Get terrain. No, we don't have on placement. We don't have it here. That's interesting. So why do we have an issue? Yeah, it's doing something. Let's see what it's doing. Let's do a breakpoint. Let's do a breakpoint. Let's go to the call. Let's go through the call stack. Here, what are we doing? A block. Yeah, we have water on placement. What's calling the water on placement? The set block type. The has blocks. Oh, here. Set block type subchunk. And where is this being called? In position details, set block type. Here on update. Blocks to spawn. Oh. And why are we getting this? Why are we issuing the block spawner to spawn the water? Why are we doing this? That's an interesting question. Block spawner. Let's see, where do we issue to spawn water? Spawn block, dirt path. Oh, maybe the fountain. Yeah, maybe the fountain. Yeah, maybe the fountain. And that's why it's like causing weird bugs. Oh, wait a minute. Yeah, let's see water. Where are we spawning water? Is water on placement? Does anybody see here a block spawner when we're searching for water? This is the block. This is block factory. This sub chunk. This world. No, it's not an issue. Oh, yeah, it's a structure. The fountain is a structure. The fountain is a structure. Yeah, that's why we get it. Yeah, we have an issue, chat. Why does this go on for infinite? Because when we run this, like, it's in an infinite loop, man. Here, it's continuing to process a lot. Like the RAM usage goes up and up and up and up to like 6 gigabytes. Because of the water on placement, because of here, this part. It's like doing it infinitely. Here we start from, oh, we don't have a breakpoint. Like it goes to the maximum. Like it goes to the, the layer goes even like negative. We need to stop it. Yeah, we need to stop it. So here, let's do it here. If node current layer is, if it's 1, do we continue? No. If it's bigger than 1, let's continue to spread it. Yeah, let's do it here. Let's do it here. So this should stop it because it was going infinitely long. Yeah, here, bro. The fountain broke. The fountain broke. The fountain broke. Yeah, the fountain broke. The fountain. Yeah, let's spawn the water ourselves. The fountain shouldn't be spreading. Okay, let's place water. Yo. Oh, I spawned the... Oh, no. I spawned the TNT to crash the game. Why are we getting this problem? I'm not sure, chat. Why is the village house cut in half? Because of it's just the rendering. It's just the rendering. Just the rendering. Just the rendering. So when we place water, it spreads, but not perfectly. Let's go to a flatter surface here. So this is the water spreading. It is spreading actually, but the levels are not. Oh no, the levels should be actually all right. And it's just killing them. I think it's just killing them for some reason. Maybe we need to add a block hover to the water just so we can see here the block state in the F3 menu. Just so we can see the block state. Because I think it's killing it. Here, I think it's killing it. Like here, the neighbor. I think it's killing it. Maybe. But at some places, we also, when we change the level, we need to not change it when it already has a level. Yeah, Jake. Thank you, Jake. Thank you. Yeah, you're right. Here, when we set the water level, we need to get the current block state, maybe. Let's just do it when it's block type of air. Let's just do the change when it's block type of air. Let's do it like that. So let's get the current block type. So here, current type equals node position get block type if current type equals air to do all of this. This should be enough, actually. This should be enough. And let's check it out. And we need to fix the culling as well. So this is the water spreading. And yo, actually, not that bad. But we need the culling here. The neighboring faces don't need to be culled. The neighboring faces need to be fixed. Yeah. Neighboring faces need to be fixed. Like, we need to see it through them. Yeah, well, not that bad, chat. Not that bad. Yeah, that's cool. And here, when it goes down, like here, it needs to go down. This water needs to go down. Isn't the culling technically correct? Well, have a good point there. We can see in Minecraft. How it is. Let's look at the reference and let's go in. Let's do it in the lava maybe, or the water. Yeah, here we can do it. Let's look at here in spectator, and let's see, is it culled? Yeah, it's culled. Yeah, here it's culling it. Yeah, okay, so it should be fine actually. So we're doing it very good. So how are we going to handle this? Yo, chat, look at this. They changed look at this. The sky is blue when we're in the water. The sky is blue. I didn't know this. They changed the sky color to blue when we're in water. Yeah, that's interesting. Yo, look at this. The sky is blue. So how are we going to do this? Okay, let's go back in our game. So this is good that we have culling here. This is actually good that we have culling. So now we need to connect the meshes. We need to remove the top part and connect it with the other part. We need to connect them in some way. Let's see here this water spread actually. So how is it connected, chat? Oh, but we have a slight issue. Look at how here it's the same block, but look at how on the left it's a bit lower, and here on the right it's a bit higher. Yeah, it's per vertex height. Yeah, the mesh is more complicated, even more complicated. Yeah, look at this, how only here on this diagonal, only on this part, it's way lower. Here it's a bit higher in the start. Here it's a bit higher. And here it's a bit higher. Chat. How are we going to handle this, chat? How are we going to handle this? From way above, it's pretty cool, actually. From here, it's very good. Like, this is the thumbnail, man. This is a thumbnail. Thumbnail in the thumbnail. Thumbnail in the thumbnail, chat. Change to this one. Okay. I changed it, and where is chat? Where is chat? Here is chat. Okay, chat. Yeah, from above, perfect. We just need to force the player to look from above. If you have control over the vertex, you should just be able to offset them based on the neighboring water level. Maybe. Could use 32 instead of 64. Looks like when moving, do the live bitrate. We need to find a lower resolution texture. I can change the texture. We can change it to something else. Like, we can change it to the, what was it called? The bare bones. We can change it to the bare bones texture. Yeah, let's change it to the bare bones texture. Fuck. Here, bare bones, Minecraft, moderate. Like this. And yeah, let's download it. Or maybe I already have it. For which version? Let's do, I don't know. Download. We can put it in downloads. Why not? We can do it in downloads. Oh, I already have it. Okay. That makes it even easier. Bare bones. Let's extract it. And I'll show you how I update the texture pack. Here, we need to go to the resources folder. And here in block. Yeah, this part. We need to delete all of this. Here, let's delete this. And from bare bones here, we just open this and go in assets, Minecraft, textures, block. We copy all of this to here. We copy it. Like this, and I need to change the scaling. Because it was way scaled to 64. We need to scale it down. So I think it was in the world. Yeah, here to 1. Let's test it if bare bones is working. If bare bones is working. We're missing a texture, which is campfire top on. Yeah, I'll get it. And I'll look at this texture as well. Whimscape. Minecraft. What's this? Gallery. Oh, this is a good one. But why are we missing the campfire top on? Campfire. What's the campfire? Yeah, this is the bare bones. Here, block, campfire. Campfire, this is the animation. Lock. Yeah, it doesn't have all of the blocks. I can get them. It's not that big of an issue. I can get the blocks. I need to go in. Where do I need to go? Backup. Backup, no. More backup. Here. Okay. So campfire. Yeah, okay. I have an idea. Here we can do like this. Let's copy the Minecraft ones here. Copy them here. and skip files that are the same. And here they add the ones we're missing, most likely. Let's run it again. Campfire top on. Where do we get it from? Campfire. Why are we missing this texture? Let's search here campfire top on. Who needs this texture? Campfire top on. Where is this being used in? Search for just campfire. Campfire. It's not used anywhere. Yeah. So here it's complaining that it cannot get a texture called campfire top on. There isn't a texture like that, and I don't know who requires it. Who is asking for it? Oh, animation. Oh, it's an animation. Bro, it's an animation. It's an animation. Campfire. Which animation? Animate Atlas. Campfire top on. There isn't an animation like that. At least here. Okay. I got it, chat. I got it. I'm searching in the wrong folder. I should search here. Campfire top. Yeah, this thing. Let's delete this animation. This will fix it. Yeah, let's restart. It was an animation file. It was an animation. Here, image frames. I need to fix this. Where did we use this? Yeah, this was for scaling, maybe. Height and width. Never wipe code. Yeah, this is a height 486 and a width. Bro, what is this width, man? It's impossible on image to get a width like that. Which image is this? Water still. Which image is this? Water still. Is this one? And this one is like 32 by 16 by 16 should be. Yeah, 16 by 16. And here I'm getting like image height of 486 and like, yeah. It doesn't have the proper heights. I'm probably missing somewhere scaling stuff. Scaling problems. Right, chat? Atlas images. Where do I use this? Do I anywhere scale this? Oh, plus images. Begin, erase. What's this for? Where do I create the texture atlas? Where do I create it? Create texture atlas here. Sure. Image. This is the image. This is the whole atlas image. Atlas size. Here the problem is the image doesn't have the proper height and width. And I'm not the one loading the images, like it's Raylib loading the images. And this is for the for animations. This is for animations, I think. Here, why am I doing this? Index. Animate Atlas. Yeah, this is to animate Atlas. I go over the animation method. Yeah, where do I handle this? Yeah, this is animation problem. It's for animating the textures. Yeah, here. Here is where I set them up. And what do we do here? What's this? Did I know there was a stream? Did I miss anything important? Depends. I don't know, chat. We just changed back from like a 64 resolution texture to a lower resolution 16. I changed one place because I manually need to change the scaling to use lower resolution like 16, and I did that, but I've probably missed one other place. Could be a different compression algorithm. The image that's not supported. Maybe, chat, maybe. Cleaning cache. Oh, okay, we can do that. We can clean the cache. Delete cache. We can do that. And we'll run it again. Most likely it'll be the same. I'm missing somewhere code. I'm missing somewhere code. That I'm... Somewhere where I've scaled... Oh, here, scale, maybe, like this, scale. And right now it's 1. I'm probably missing some place where I forced it to be 64, big resolution. There's probably a place like that somewhere that I'm missing. And here it's like complaining with the animations. Complaining with the animations. Because when it gets an image, we get how many frames there are by like dividing the height by the width. Because the width stays the same, the height for the animations is like very big. That's how I get the frames. But here the issue was the height and width were wrong. Like here, like they are not correct here. The height and width, they're not correct. And what's the image? Do we have actually... Yeah, look at this. Like height and width are all wrong. They're all wrong. Here we're looking for water still animation. Here do we have water still? Do we have it? Yeah, we have water flow, but we don't have water still, I think. Do we? Yeah, we have water still. Oh, here height and width is 0, I think. Oh, it's empty. It's empty. Oh, so here we just need to do an error. Here we just need to do an error when it's empty. Like that. Other has no model. Yeah, but here we're going over the textures. This is different. Here, if is image valid? Image. If it's not valid, throw invalid image for animations. And let's test it again to see if it throws. Let's see if it throws. Yeah, it throws. Image is not valid. And it's for the water still. Perfect. Okay, chat. Do we have the water still? Water flow, overlay, and water still. We have it here. This is the water still. And we have here the animation meta file. Oh, wait a minute. The bare bones, I think it was very empty. Actually. Let's use the original water. From the original. Yeah, let's use the original. Excuse me. Use the original for the water. Replace the files in destination. And let's rerun it. Okay. So we're back with the bare bones texture pack. So we did this because of the bitrate. Guys, is the bitrate fine? Because somebody complained the texture pack was too high of a resolution. Yo, look at the crying obsidian. It's cool. Oh, the particle effect is broken. All the particles. Yeah, I need to change the particle. Yo, the TNT. Yeah, TNT. Oh, nice. Let's go back to business, chat. Let's go back to business. Can you make color lighting? Minecraft doesn't have color lighting. This has the animations. This is animated. Okay, let's do the water. Where's the water? Here is the water. Here is the water. Oh, the portal. Let me just see the portal. And this is the portal. Yo, nice. Okay, so the water, and this is the water. It spreads. This is the water. This is the water, chat. This is the water. This is the water, chat. So, let's make it simple. Let's try to connect it some way. Oh, Let me think about it, chat. Let me think about it. We need a custom model. We need a custom model. We need a custom model. Like we could like here just have the neighbors here to just add the neighbors and it will be kind of fine, so we can continue. Yeah, let's just add the neighbors. Let's not kill it. Let's add the neighbors. Where is it? Where do we call them? In sub chunk. Here where we generate mesh. We'll draw a face. And if both the current block, let's do true actually. Let's do true actually. Oh, but this will be a big mistake. We need to kill the water. We need to kill it actually. Because it will draw too many faces for when we have like a lot of water. Yeah, that's a mistake. That's a mistake. We need to kill it. We need to kill the neighbors. We need to kill them. For sure. We need a custom solution for flowing water, generating the mesh. We need a custom solution for sure. We need custom solution. So what will be the solution, chat? For which is the priority? Let me think about it, chat. Let me think about it. How should we handle the water? How should we handle it? Oh, I have an idea. Yo, let me just look at here. Yo, the road. The road is cool. Okay. Let me think about it. Let's open Minecraft through our helpful application. Let's close it so we can open it with extra details. Let's open render doc. We need to see how many draw calls they do. We need to go in documents. Where is render doc? And then I need to do this launch. Okay, I'm starting Minecraft. 1 second, chat. Yeah, okay. We're starting Minecraft with a bit of extra detail just to see a bit more information on the water. I want to see if the water mesh is being drawn separately from everything. So we'll go near an ocean. Somewhere. And we'll have flowing water temporarily. And we'll look at through render doc to see the draw calls. We need a bit more information for drawing the mesh. We need a bit more information. Because here, like it will be a lot easier if I have a separate model just for this flowing water. If I have a separate model, to make it a bit easier. So I can custom make it with like custom vertex height, etc. To custom make it. Because right now I'm very limited. Okay, so let's go somewhere near an ocean, like this, like still water. I just need still water. And here with this flowing water, let's see the draw calls here. Let's see the draw calls. This is perfect. Our focus is there, the flowing water. is our focus. Let's do a screenshot. And let's do, where is render now? Where is it? Here. And let's look a bit of information. We need a bit of information here. And let me think about it, chat. Yeah, let's go through the draw calls. And let's find the water. Where do they draw the water? At the end, somewhere. Where's the water? I don't see water. Oh, I see water now. I see water now. Like this. And that there is the flowing water and it connects. But here first this initial draw call. I want to see. This is the render doc. Yeah, this is the draw call. This is the draw call. This. Okay, this is my focus and this is the wireframe. Like this. So here this water is still water, but here this is flowing water. And they're being drawn in the same draw call. In the same draw call. What about if we have lava as well? I want to see that. Let's see if we have water as well. Are they separate? Are they separate? Let's do water. Oh, let's do lava. I want to see if the lava is a separate draw call. Let's have multiple ones just to be sure. Just to be sure. Like that. And let's do a screenshot. Like this. And let's look it up. Lava. So let's go. Oh, interesting. Yo, interesting. Lava is drawn with the terrain because it's not semi-transparent. Interesting. Is drawn with the terrain. Interesting. I didn't know that. Like because of the mesh, building of the mesh. Because of building. Okay, so they build a mesh with all of the other blocks. They build a mesh with all of the other blocks. That's interesting. That's interesting. Chat. Let me think about it, chat. Let me think about it. So how am I going to handle mesh generation? How am I going? Oh, it's fine. It's fine. Oh, like all the time. No, it's fine. It's fine, guys. It's fine. Here, where was it? Block. Here, and we have a custom function, generate mesh, and it will be dependent on the current block state. Yeah, here, generate mesh. This thing here. We'll handle the mesh generation here. Usually we use this. We have a mesh context. We have a current mesh context where we push the vertices, all the vertex data. We push it here in this mesh context, which just has a vector of positions, a vector of normals, a vector of UV zeros, which is the texture coordinates probably, vector 4 of colors, and vector of unsigned shorts for the indices. So I can just have the logic here. Where I generate everything. How are we going to handle this? We need to decide how are we going to... And the only information we have is the layers. That's the only information we have, is the layers of the water. Yo, fire looks cool. You know hidden water flow mechanic? If you make hole near water, flow there? Yeah, I know. Yo, this is the fire. Fire is cool. Here we have a cave. Okay, let's place the water somewhere. Let's place it here. Here. Let's place it here. Let me think about it, chat. We need to generate custom mesh. We can easily generate custom mesh from here, from this function generate mesh. Like the game goes through the water block and asks the water block, give me your mesh data. And I give the mesh data here to this mesh context, which has vectors of positions, normals, UVs, colors, etc. So I need to generate the custom mesh here, and I'll do it depending on the water level. Depending on the water level, and we don't need to handle culling, it's fine. We don't need to handle culling. Because with the custom mesh, there are no neighbor issues. So I want to make it simple actually. I want to make it simple. Here, I need the neighbor actually. I need the neighbors. Maybe. Let me think about it. No, chat, I need to look again. Reference. I need reference. We can do each vertex to have a height. Yeah, I changed the texture pack to... because chat was having issues with the high resolution and the bitrate of YouTube. I'm setting name. We can have vertex height. Each of the... like we can have here vertex height. Like here. In each of the 4 corners, we can have a height level. That's something we can do. So here it can be... here, when we place like water, look at here. The vertex height is like almost 16. Let's say it's like 12 or like 14. Let's say here it's level 14 for these vertices. But here for these corners, this corner is like half, like maybe 4 level. Here level 4. And when we have a certain level, and you check the Minecraft wiki, there were heights for the... I don't need exact heights. I don't need exact heights right now. We're doing something else. We're generating this mesh. Yeah. 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 Each corner will have a height level. Each corner will have a height level. And depending on the level, we decide how the cube will look like. But wait a minute. Oh, we have a bit of an issue actually. Yeah, let's look at the mesh. Let's look at the mesh because it gets a bit complicated. We need... think about it, chat. No, it's not complicated at all. It's fine. It's fine. It's fine. It's fine. It's fine. It's not complicated. It's fine. It's fine. Yeah, let's have each one to have a height level and we'll generate the cube. Yeah, let's do that. Let's do that. Yeah. Yeah, let's do that. Let's do that. We need... but it will be custom mesh generation. It will be custom. It will be custom. It will be custom mesh generation. Yeah, but it's worth it. It's worth it, chat. Yeah. So every corner of the block, like... this is one block. Every corner will have a height level. And depending on the height level, we'll have a generated cube. Like this. It should be simple, actually. It should be simple. The problem is we need to do it manually through code. I don't have an abstraction for this part. I don't have an abstraction. Because usually I handled it through here, cube mesh pool. I handled it through like this generate method, and here I had many steps. Yeah, we need to generate a cube. We need to generate a cube. We need to generate a simple cube. We need to generate. Oh, wait a minute, but we need to cull the sides as well. We need, yeah, do we? Yeah, here. The neighbors, we need to cull neighbors. Yeah, we need to have, because here, this part is visible. But if we had water here, it will make it invisible. Like if we had water as a neighbor. Here, now it's invisible. Like it has culling. Yeah, so we need also culling as well. We need culling. That's a bit of an issue. a bit of an issue. It's a bit of an issue. Hey Pizza, I do. I'm not looking for help. Let me think about it, guys. Let me think about it. We can like straight away start working. What do you mean? We can straight away start coding here the custom mesh generation. Sure, we can do that. But it will be hard. It will be hard coded, and it will be very ugly. And it will be a bunch of code, and we need to handle culling as well. And how are we going to generate block depending on the corner height? How are we going to do that? Yeah, let's look as inspiration Raylib. Let's look at as inspiration Raylib. Here, let's do generate mesh cube. And here, like this. Yeah, this is how they generate a cube. This is how Raylib does it. This is how Raylib does it. They don't have culling here. They don't have culling. But if we ignore culling for a second, how can we do something like this for generating a cube mesh, but with every corner to have a different height? So here is the height actually. This is the height part. So we just need to change this part. This is the only part we need to change. The height part. This is the only part we need to change. Yeah. And we need to find the corners. We just need the top ones. We just need the top corners to change their height. Because here the bottom ones are always like the minimum. The bottom corners are always the minimum. We just need to change the height of the top corners. We just need the top corners height. So we need to change these ones, the positive ones, the biggest ones. But here it's a bit of an issue. Raylib centers the cube, like it centers it. And I usually have the block origin be at 0, 0, not the center. I do it a bit differently. So I could just copy my... Yeah. We can copy our existing abstraction and change it a bit to handle water. That's something we can do. Here, cube mesh pool, generate. And here the template. Where is the template? Template, like this. Yeah, we just implement like to conditionally add all of the faces, all of the normals, etc. But I need another different structure than this. I need a different structure than this. I need a different structure that handles the liquid mesh generation, which also has the part for conditionally adding faces. The only difference is how we generate the actual cube, because we need size. We need a height for each of the 4 corners. Yeah, let's just temporarily make a class temporarily. Let's temporarily make one. Here, liquid mesh generation header, and it will be a singleton. And let's do a CPP file. Liquid mesh generation CPP. Let's do a CPP file as well. And here we include it. Let's stop the game. We include liquid mesh generation header. And here we need to do pragma once. And here we need structure liquid mesh generation, like this. And in the CPP we need structure. Do we need extra data? Probably not. Probably not. Let me think about it, chat. Let me think about it. How did I do it with the regular blocks? Yeah, it's just... it's not static. It's not a singleton, the cube mesh template. It's not singleton. Why not? Because I need to save data. Because one block has multiple sometime blocks uses, but here for the water can be, we can use a singleton for generating the water mesh, because every once a block will have a single like a block. It will be a single block. It will not, there will be not 16 by 16 by 16. There will not be a block that has like more than a single cube. That's a bit changed. Because here, even if it flows down like this, this here is a single block here. The single block. And it continues here to another block. Yeah, it can be a singleton. Can be a singleton. Some people like the... I don't know why chat started talking about AI. You guys started the whole conversation on AI. Liquid mesh generation. Let's make it a singleton. Here, let's do a structure. Data. Liquid mesh gen data. Here we'll store the data and it will be a static. Liquid mesh gen data. And so what now? We need to define a few functions. We can use as reference my previous mesh generation stuff. Yeah, we can have clear, we can have clear, next phase, generate, conditionally add phase, normals, UV0, indices, what's UV, color maybe. Bro, it's very similar. It will be a lot simpler if we just add it to this mesh generation abstraction to have functionality for adding the water. It will be a lot simpler to add the functionality here. It will be a lot simpler. So maybe, oh yeah, okay, that's what we're going to do, most likely. Yeah, that's what we're going to do. We'll give it, when we generate the mesh, here we'll give an integer that has data for all of the four corner sizes. Corner heights. We'll handle water here. Corner heights. We'll handle it here. Yeah, we'll not be creating separate. We're not going to do something separate. Yeah, let's handle the mesh generation. Okay, so when we generate the mesh, we need the corner heights, and we can do it with a single integer. How? By packing data. Like usually an integer is like here. Ones and zeros. This is an integer. And it's 32 bits, 4 bytes. So here we have like many zeros. Like we have 32 zeros. And we can use these 32 bytes, 32 zeros, by storing, for example, here will be the height of the one corner. Here will be the height of the other corner. Here will be the height of the other one, and here the final one. We need 4 integers inside of this integer. You'll see what I mean, chat. You'll see what I mean. Do you have any game project that you want to publish? I want to publish this one, but not right now because it's copyrighted. I need to make some changes, but I'll publish this one. Hopefully. But not in the state it is now. Let me think about it, chat. Yeah, here we need integer we need the corner heights. We need the corner heights like this. We need corner heights and what else do we need? What else do we need? What else? What else? What else? Let me think about the chat. We need to change the pool as well here when we generate. Where do we? Here we generate. Here by default it will be the maximum. It will be the maximum, but how much? We need values from the corner heights. They can be from 0 up to like 16 maybe. Up to 16. So if we do 2 to the power of 4, how much is that? 16, yeah. So we need 4 bits, so 1 byte. 1 byte, we need 1 byte. 4 bits. And so the maximum, what's the maximum? What's the maximum, chat? Decimal to binary, what's the maximum number? Like here we can do like CPP binary. I want to write a binary number. How do like 0B? Yeah, 0B. Here, 0B. Zeros. How are we going to do it? We want 16, 16, 16 and zeros. Right? Like by default. Like by default. What's the number by default? 16 convert. Oh, it's just this. So 1, 2, 3, 4. So 5 digits. We need 5 digits. We need 5. Okay, so binary to decimal. Binary to decimal. So like this. This is one corner. 1, 2, 3, 4 corners. Convert. So this is the default. If all of the corners are with height 16, this is the default. This monstrosity. This monstrosity, which nobody will get. Bro, look at this, man. Generate the mesh. First argument 541200. Cool faces and ambient occlusion neighbors. Bro, nobody knows what this number is. Nobody knows what this number is. I should name it something. How should I name it? Integer. Yeah, corners height. Corners height. Corners height. And here to be like 16 height on all 4 corners. Like this. Corners height. Bro. Like this. This makes a bit more sense. This makes a bit more sense. So, and the water will change this argument. When we generate the water mesh, we'll give different corner heights. But let's now actually use these corner heights. Let's actually use them when we generate the mesh. Let's actually use them. How are we going to use them? Well, let me think about it. We have them here where we add the vertices here. When we add the vertices. Yeah. Here. Here. We need to use the corner heights here. And damn. Yeah, and this is my cube mesh. I use the unit cube from 0 to 1 on all of the axes. So here the height, we just need to change it to be... maybe it should be like from 0 to 16 actually. So we don't need to divide for deciding on the corner heights from like when it's from 0 to 16. So when the corner height is 0, the top here, this will be like 0. Or like, let's say the corner height is like half. Because here, in order to have liquids, we need to be able to set each corner the height of it. We have 4 corners here. This one, and this one. We need to set the height. And here the height is kind of the middle. and here it's almost to the top. And so when we tell it to use the corner height of the half, and it's just one of the vertices actually, it's just one of them. So I need to actually figure it out which one it is. That's a bit of a bummer. And if we change this, if we change this, we need to then clear it, reset it back to how it should be. Maybe. Or no, we can just multiply. We can just multiply the Y level. We can just multiply. Oh, yeah, chat. Yeah. Yeah, we can... yeah, here we can just add a bit more data here. Corner heights. Yeah, we can just do it like this. Int corner height. Which corner? How are we going to label the corners? So we have east, like we have the like east, west, and north, south. So how are we going to name them? The east, the east, north. How are we going to label them? I was going to label them like the east, north, then the west, north, then the east, south, and the west, south. Something like that. Or northeast, northwest, and then southeast, southwest. Something like that. So here, this is the, where is the, yeah, this is the south, and this is the north, and this is the east. So this is the north, this is the south. So southeast is this corner. Southwest is this corner. And here north, this is north. Yeah, north. Northeast is this corner, and northwest is this corner. So that's how we're going to name them. Northeast. This is south, and this is west, and this is a west, like this. Okay. And we need to give them defaults. We need to give them defaults to the values. Yeah, let's go to the water Wikipedia page. And here, let's find for the water levels. Water, like the heights. Height of water 8 is used when falling is true. Sure. I need more exact heights. Let me think about it. No, it's fine. It will be between 0 and 16. Let's just say that. Let's hear corner height. Corner height. This is for the vertices. Like that. So let me think about it, chat. So we have the corner heights. Let's actually use them. And let's reset them also here in the clear. Let's reset them to be the maximum. What's the maximum? Let's say it's 16. I don't know. Let's say it's 16. The corner heights. Let's set them to be 16. It's by default always to be 16. By default. Let's make it different. Let's make it be 8 by default. Just so we can see it works. And it will change for all of the blocks. Use 15. No, I think 16 is better. If it's a problem, we'll use 15. Oh, yeah, you're actually right. Yeah, but it's fine. The options needs to go up to 16. But let's leave it at 8. Just to test it out. And let's actually use them. We don't need these corner heights. We don't need them. We don't need them. We don't need them here. We don't need them here, and we don't need them in the mesh pool. We don't need them here. Perfect. Okay. So let's actually use them in the template. And let's actually make it a little bit, let's make all of them different values when we clear them. All of them different values, so that we can be absolutely sure it works. Let's make the north be 16. And guys, this will be for every block, and the south be 8. This can be for every block. We'll set it to be only for the water, but for now it's for every block, just for testing. And how are we going to handle this? How are we going to handle it? Where are we going to use these heights? Because here, when we generate the mesh, we add all of the faces conditionally. Here, this is the top face. This is the top face. This is the top face. We go over from, starting from the 0, we go over 4 vertices. So starting from the 0 here, we go over 4 vertices, these ones. This is the top. This is the top. How do we add them? Let me think about it. Yeah, we get them from the unit cube. This is the vertex position. Oh, yeah. We have a from and a to. This is from the mesh generation. From plus size. Yeah. Because we are implementing the custom mesh generation. Let me think about it, chat. From plus multiply by size. Yeah, and we have different sizing. And then we divide by 16. We need to override them. Here we need to override them. We need to override them. Yeah, the vector 3 height. Yeah, the y value here, the y value. But is it every y value? Is it every y value? We need to override it. We need to override it. And what's from and to? Where do I get them? Here. Do we reset them? Do we clear them to 0 and 16? Do we clear them? No. Yeah. Let me think about it, chat. Think about it, chat. Where did we do it? We did it here. Yeah, here. Here is where we generate the mesh. And let's go back to the cube. So when okay, chat. Okay. So when the value is 1, we need to change. We need just to multiply the y value to the height, like to the corner height. But we need to figure out how to know which vertex we're currently on. We don't know that. Which vertex we're currently on. We don't know that. We don't know that, actually. We can do it after we add the vertices to override the height. That's something else we can do. And where do we add the faces? To positions, these positions here. Sure. And current face. And we call this. And after we call it, we go to the next face. Okay. Yeah, okay, so we'll do this loop again. Okay, we'll do this loop again. Where do we need to do it? We need to do it on the top mesh, for sure. We need to do it on the top mesh. We need to do it. We don't need to do it on the bottom, but we need to do it on the north, south, east, and west. We need to do it on them as well. Yeah, let's manually override the height. If the height is like, we'll see. So here, before we go to the next phase, here we need to go over all of the faces. We need to go over, but we need to do it carefully here. Because we have the northeast, northwest, southeast, and southwest. We need to properly do it. So here like northeast, corner height. Here the Y. This to be multiplied by how much? By how much? How much do we... No, we need to divide it by 16. Right? Oh, like multiply by 116. It's kind of the same. Yeah. We'll do this. We do this 3 times. This is 1, 2, 3. In total, we do it 4 times. And this is north. This is northwest. This is south. This is south, and this is west, like this. But we need to match them correctly. We need to match them correctly. Because here, what's the first corner? So here we are on the top. So the first corner is 0 on the X and 1 on the Y. So yeah, okay, so is this north? What's the positive? Positive is the south. And north is 0. Okay, let's swap. We need to swap them. Here we need to do south here, and we need to do north here, like this. We need to swap them. Is it the same error? 1 1 0 0. But here it's 0 0 1 1. Yeah, it needs to be specific. So can I like temporarily, like, I need this as reference to the sites, because I'll be looking at it again and again, so I don't scroll constantly. And here let's do Excalibur. I'll put this on the second monitor, guys, and will not be able to look at chat, just so I can see. No, I can look at chat, it's fine. I can look at chat. Okay. Here, okay. So this is the top, this is the south. Yeah, this is the south and then the north. But do we do it correctly? East, west, is that fine? So the X is 0 and 1. 0 and 1. West is 0, east is 1. 0 and 1. So west and east. So this should be west, and this should be east. And then 1 0, east, west. Okay, the top is done. We're okay. The top is good. But wait a minute, guys. Let me think, chat. Let me think about the culling. Yeah, it's fine. Yeah, the culling is fine. Bottom, we don't need to change it. Bottom is fine. We don't need to. The bottom is always 0. It's fine. So let's do the north. Yeah, let's do the north. And here, what needs to be the order? Here, we just need the, where's the north? Okay. We need to change only 2 of them, the top ones, these ones. We just need to change 2 of them, and it's 0. Wait, this is the north. So we need here north. Yeah, okay, it needs to be the north, but east-west, is that fine? So it's 0, 1. 0, 1. So it needs to be west-east. Here, west corner height, and here, east corner height, like this. Perfect. So that's the north. Let's do the south. Let's change the south mesh height levels. So this should be south. So for the south, it's 1, 0. So east, west. East, west. Like this. And let's do the west. Let's do the west. The west is 1, 0. So that's 1, 0. So south, north. South, north. And all of them on the west. All of them on the west. Perfect. Let's do the east. So the east is... What's the east? The east is 0, 1. So that's north, south. So it's north, south, and here is just the east. It's just the east. Anything else? No, that's it. That's it. Perfect. Perfect. So now we test it just to see if we have custom like mesh generation, like for all of the blocks. Let's see if we have custom mesh generation. What's the issue? Generate mesh cube, generate mesh water. Oh yeah, I forgot to remove this. It's fine. It's fine. Yo, chat. Yo, look at it. It's sloping down. Yo, it works. Look at this. It's sloping down. Triangle craft, chat. Triangle craft. It's sloping down. Yeah, so it works. So it works. Yeah, it works. So we just need to do this for the water. We just need to do it for the water. But it works. Yo, everything is like this. Even the lever. Bro, look at this lever. Look at this lever. Look at this. Yo, the texture. And the torch. Oh, look at the torch. Cursed. Then it's an abomination. Oh, the glass. Yo, look at the glass. Yo, chat, look, custom glass. We have custom glass. What about the leaves? Or cactus? Cactus? What about the leaves? Oh, portal. Leaves? It's fine. Oh, the anvil. And the anvil is broken. Stacked block. It's just killing the top side. Okay, let's do the water. Now, okay, so it works. So it actually works. It actually works. Let's change the default to be 16. Default needs to be 16. And only for the water, we'll have custom vertex height level. Only the water will... Okay, so now everything is back to normal. And we'll change... Yeah, even the water is like this. Oh, no. It forces everything to be this height. Not everything needs to be forced to be top. Like this, the dirt path. Dirt path was like this, a bit lower. And it breaks stuff if I force it. Yeah, it breaks the anvil as well. When I force it to be maximum height level. Yeah, it forces it. Yo, who is causing problems in chat? Alex, who's causing you problems? I'll ban him. Who's causing you problems? Where is he? Yeah, he's causing you problems. Who is this? Who is this guy? Where is he? Yeah, chat, where is he? Where is he? Ah, this guy. You're gone. He should be gone now. Should be gone. Okay, so let's solve this. Okay, so we should focus on... Yeah, sorry chat, I didn't know chat. Guys, when somebody is annoying you, tell me, I'll ban him chat. Like, don't... like, doesn't matter chat. We can go down to 0 viewers chat. It doesn't matter. I want you guys to have good experience watching. I want you guys to have good experience. Like, if somebody is annoying you, tell me, I'll ban him. But it needs to be like... it needs to be with good reason. It needs to be with good reason. So let me think about it, Chan. Let me think about it. I'm from Bulgaria. So how are we going? Okay, so we can change the height of the corners. That's perfect. We can change that. How are we going to force it to be only for the water? How are we going to do that? To force it only for the water. Because right now, we are changing the height for all of the blocks. Like here, even for the snow, like even for the like torch, we're forcing it to have like maximum height. We're forcing it to be maximum height, which looks very weird. How to make it to be only for the water block when we generate it? Let's have a boolean. Okay, let's have a boolean. Let's have a boolean flag. Custom height, maybe. Boolean custom height equals custom height, custom corners height, like this. Custom corners height. And when we generate it, we'll change the heights if this is true. If we have custom corner height, like this, and we need to do it for the north, need to do it for the south, need to do it for the west, for the east. That's it. So for the north, for the south, for the west, and for the east. For the east, and we need to reset it to always be false. Always be false when we clear it. Where do we clear it? Clear. When we clear the data to be by default always false. And just for the water, we'll set it to true, and we'll have like custom corner heights. We'll have a custom corner heights, and we'll have the water mesh. That will be very cool if it actually works. Let's test it. Now it should be everything like normal, and we'll focus on trying to do it for the water. Like this. Okay, nice, nice, nice. Everything is back to normal. Perfect. Okay. So let's focus on the water. Let's focus on the water. Let me think about it. QMesh pool. What are we going to do? We have a function to read from JSON file. Here we'll do something else. Static void. Load water. Generate load water mesh. And we'll generate it. And we need int water level, maybe, or like to give it the let me think about it. We'll set here corner heights, maybe. Yeah, so northeast height int. Yeah, let's do that. Let's do that. So this is northeast height. But this is water mesh. We'll need to do the same for the lava as well. Which will be set liquid. Liquid mesh. Yeah, liquid mesh. Here this will be northwest. This will be south. And this will be southwest. Perfect. And here it will be very simple. Will be very simple. We get the template. We clear it. Here we clear it. Or we can think about it. We can just load by default. We can load by default just a water block. We can load a water block mesh and just change that mesh height. That would be much simpler. We can change that. We can get reference here to a block. We can do that. But why do we need it? This reference, why do we need it? Block ID, just to get block ID. Low-key Pets is so organized with his code, could never be me. Bro, what do you mean my code is organized? Let me think about it, chat. We need to load in the just the water block mesh. We need to load in that JSON file model name. Yeah, read from JSON file. Let's do that. Let's look at the current implementation block. Current one. We need to do this thing. Yeah, this is what we need. Okay. Yeah, this is what we're going to do. Okay. So we'll get this. We'll give it here. We'll give it here. We'll give it here. And we'll use it here. And we'll generate a mesh, but just the water block mesh. We'll generate the water block mesh. We'll generate the water block mesh and we'll edit its height levels. That's what we're going to do. So in the where exactly? In the CPP here, we generate this. Okay, we generate the water block, and here we need the block reference. Okay, we have the water block, and here we need cube mesh. Yeah, but this will issue the next template. We can I need the current template. The current template here, because I need to change the levels. Here, cube mesh pool template. Get template. Yeah, templates. This thing. I want this thing here to be here, and here. Here I know it will be the first template. It will be the first template, and I just need to set up the northeast corner height. And the same for all of the other ones. Here the south. This is the west. This is the west. and south, and this is the west, and this is the west. Perfect, perfect, perfect. And by default, it's just the water block. By default, just the water block. And so now let's go back to the water. Go back to the water. Where is the water? And generate mesh. And here, how are we going to handle this? We have the layers. We don't need JSON model file name. We don't need this. And here we want, let's remove this. And we want, what do we want? What do we want? Here, instead of reading from a JSON file, we want load liquid mesh. And here the heights. Here the heights, let's do them by default, be like the north be 16 and the south to be, how much to be the south? 8. So just the water will be it will look different. Just the water will look different. Just the water will look different. Wrong JSON model name. Which one it is? Water block. Why is it wrong? Liquid mesh here. Oh, yeah, this part doesn't need to have spaces. Okay, let's see. Just the water block needs to have now a different shape. And we'll then, yeah, let's test it. Just the water block. It's 16 height everywhere. It's 16 height. What's the issue? What's the issue? What's the issue? Think, Mark, think. What's the issue? Why it's 16? Oh, I need to set it to true. I need to set the boolean like cube. I need to set that it has custom height. Custom to true. That it has, I need to set the flag to true. Why do you find it impressive that I'm using C++? Okay, guys, water. Look at the water, guys. Look at the water. We have, okay, we can change the height level of the vertices for the water. Perfect. This is exactly what I wanted. Slope water. Detective Jones. I joined at perfect time. Okay. Yeah, this is good. This is very good. Okay, so now we can actually change the water levels. We can change the water levels right now. Water stairs. We got water stairs. So how are we going to handle the height? Are we going to handle the height? Are we going to... Let's... okay. Let's change it. Back in the water. Here. When we... Here for the height, let's just do the layer. Here for the height. Let's just do the layers times 2. Because it's up to 8. So now it should be like before, but we'll make some changes. We'll make it so it changes depending on the center of the water or where it was placed. Here, like this. Let's place it. Sure, okay. So now we need, okay, now we can finally change the water height. Let's commit this and let's figure out what height levels we're going to use. Here. Yo, we made so many changes. Oh, that's because of the texture pack. Can change mesh height level. For corners, but to make players slower in water. We're not focusing on that. So chat, what? Okay, so we can change the height level, but we have a slight issue. We can lower this corner down, lower, like here. Oh, it depends on the flow direction. Here, these corners needs to be up, and these corners to be up because of the neighbor. Oh, because of the neighbor, because the neighbor has higher height. Let's look at in Minecraft how it is. We should be able to now do it. Should be able to. We in theory should be able to do it exactly like in Minecraft. Exactly, we should be able to do it. So here, how is the logic? Oh, look at how here it has flow direction towards here, towards here. It just goes down. It just goes down. That's interesting. It just goes down. And then here. Oh wait, the cat came. I need to see the cat. I'm back, chat. I'm back. In cat reveal, bro. She doesn't need publicity. It needs to be offline. So here, look at how the flow is just straight down. It's just straight down, and here is just straight down. Oh, let's do that, chat. Let's do that. Let's not spread it diagonally. Let's just do it straight down, just so we can focus on the mesh. Let's just focus on the mesh, and then we'll do the corners. Yeah, that's much better. That would be much better. Okay, let's do here to go like this and this and this. Oh, I know how to do it. I know how to do it. Okay, let's do. Oh, chat, that's perfect. Actually, that's perfect. Yeah, here in the BFS. Here, no, we need a water flow. We need a water flow. We need water flow. We need water flow. We need a water flow. And how can that be? We have culling of fluids. We have culling. How can we save the water flow? Like it needs to be a direction, like left, right. Yeah, the water flow can be just like either of the two directions. It can be either of the two directions. The water flow. It can be either of the two directions. Oh, yeah. Oh, chat. Yeah. But... and we need informations for the... oh, okay. It will be block state. It will be block state. Yeah, and the corner heights will be block state as well. They will be block state as well. And the flow direction. All of that will be block state. Yeah, I've decided. And this will be just a liquid class, and water and lava will inherit it. Something like that. But for now, it's fine to be just in the water. So we can do it faster. Yeah, chat, yeah. Yeah, I've decided. Where are the properties? And we have like 22 minutes, chat. We have 22 minutes to figure this out. Let's speedrun this, chat. If I was doing this off stream, now would be a perfect time for copyrighted music. Just to get in the flow, but we're on YouTube, chat. I cannot put like Taylor Swift. Okay, I will not put... it will be different, a different song. It will be different. Let's create block state. Where are the properties? I need to create custom block state just for the water, but where are the properties? Yeah, properties here. Not this one. Here, property, here. Yeah, we have layers. We need a few extra ones. We need a few extra ones. So we have mode, layers, unstable, persistent, snowy, lit, age, power. So corner heights will be an integer, just like the layers. But it's just for all of the corners. It's just for all of the corners. I should have a property parent, like an integer property. So I don't have to repeat all of this. So I can directly inherit it, but let's say it's fine. It's not fine. Let's do integer property. Here, int property. And we'll inherit from it. Int property. And here, make shared. Oh, but I cannot do this. Was it going with physics? What do you mean? I need to handle get copy separately. I need to handle get property separately. Yeah. We need to separate it. Okay, but it's fine. It's good enough. It's good enough. And so here we can do the corner heights here. So here we do, this will be north, east, height, northeast height. And this will be in property. This will be integer property. And here northeast height, we'll just call the in property key, like this. Like that, chat, like that. And we don't need toString. We don't need this, but we need get copy. We need get copy, I think. Northeast height. Northeast. No, we can, no, it can be in the in property, I think. But I'm not sure. It should be, I should be able to have it here, int property. Should be able to have it here. Is this an override? No, it's not. Or it is? Should be. Oh, it's fine then, it's fine. Okay, this makes it very easy. So we need 3 more corners. This is the northwest property. This is the south, bro. This is the south. This is the south. Southwest. Southwest. This is the northwest. Oh, this is the northwest. Yeah, and here. And like that. Okay, it's fine. Okay, we have the corner heights for the water as block state. What else do we need? Thank you for follow, Paddy, on Twitch. What else do we need as block state? We need the direction, the water flow. We need water flow direction. And how do we handle it? How do we handle it? We can do like facing. We can do facing. Facing. So it's up, down, north, south, east, west. Perfect. We can leave it as facing. Just facing. We can leave it as just facing. Does it compile? Let's see if it compiles. Should compile, probably. Perfect, compiles. Oh, but what's the default flow direct? Oh, if it's still or not. We need also if it's still or not water. And if it's not still, then it has a facing direction, the flow direction. Yeah, let's do that. Here, structure, flow direction, it will inherit facing. And let me check out facing. What constructor does it have? It has two constructors. It has two constructors. And here we have flow direction. We have key. No, we have like facing the key. And here we have facing V. Like that. Okay, we have flow direction. And what else? And we need if it's still or not, so a boolean. So let's see one of the booleans here, and let's just make a boolean parent. Make a boolean parent. Here, bool property. Or like, what did we call it? In property, bool property. And bool property, like that. And here, bool property, like that. And that's it. And we need if it's still or not. Still, if it's still or not, and here, public bool property. And we need a constructor. Here we'll use boolean key, and we want bool property key. And that's it. That should be it. That should be it. So let's do some defaults. Let's do some defaults for a block state of the water. Let's do some defaults. I'm from Bulgaria. Man, that question has been asked many times. Copy these values so I have reference to them here, because I'll need to look at them. Okay, so let's give default values. Let's give some default values when we define the water block. Water here, instead of having layers, it will have something different by default. Here it will have north. I need to rename them probably. Northeast height. Yeah, it's fine like this. And here to be like 16 by default. And then here north west. And here to be south. Oh, brother. South. And here southwest, like this. Okay. And by default, it will be still. True. By default, it will be still water. And direction flow, or maybe water that flows is different. Water that flows, maybe. It's fine, it's fine, it's fine. Don't worry about it, it's fine. Flow direction. Like, we can put whatever we want here, it's fine. We can put like north. We can put north. It's fine. It's fine. And now we actually need to process these properly in the parser. We need to process them. And where did that happen? In world, probably. Layers. Layers. Here. Add property. We need to add property here. We need to add a couple of them. We need to add northeast height. This is south, southwest. This is northwest. And here this will be northeast, northeast height. This will be south, but this is west. This is west, like that. Okay, these are the 4 properties. We need still, and we need flow direction. Perfect. So this should be kinda enough. But now when we search for the layers, property in the water, it will not find it. We need to remove that. Where do we use it? Do we use it anywhere? On placement, maybe? Yeah, I think here we changed the layers. It should use defaults. On placement, let me think about it for a second. Generate mesh. Yeah, we don't. We have layers here. We want here north, east. Yeah, and here we want northeast height. This will be south. Will be south. This will be south west. This will be west, like this. North, south, and here I need to change this to be northeast. This should be northwest. Should be southeast. Should be southeast. This should be southwest. We have all of the heights, and this is if it's still or not. By default, it's still, right? Yeah, by default, it's still water. Here we'll just use directly. We will directly use them here. What's the order? Northeast, then northwest, then southeast, then southwest. Okay. Northwest. I didn't change it. Northwest, like this. Perfect. And anything else? Yeah, the flow direction is fine. So what now? Let's test if it breaks. Let's see what the error is. It should have an... Oh, we didn't change... Yeah, we didn't change some stuff. It should break. Yeah, it breaks. Yeah, for the water itself... water itself on placement. Where do we... Probably somewhere we look for a property that doesn't exist. But let's see. When we generate mesh here, it cannot find northeast height. What current properties does it have? Get property. Property, size of 6. It has north, which one cannot it find? Cannot find. Badcast. But what's the key, man? What's the key? Let's go back. Here, northeast height. And what property does it have? It has northeast height. And what type is it? Do I have to like use like integer, the integer pointer as a base? Because it probably copied it like that. East height. Yeah, let's try that. Let's try that. It probably here copied it as a integer property. Probably. Let's see if it now stops on the next one. It probably copied it like that. Now, which one did we stop? The next one. Okay, that was the issue. Brother. It's an integer property. Oh, this is interesting. Let's test it out. That's interesting. Yo, yeah, okay, okay. So, okay, and by default, it's 16 height on all of them. By default, it's 16 height. That's good. That's good. That's good. Okay, by default, it's 16 height. Perfect. So now, and by default, it's still water. So what now? I wanted to have a flow direction. And depending on the flow direction to set the height. And like depending on the neighbor values to set the vertex heights, the corner heights. Here, this part looks probably bad because I need to draw them in the proper order and it will be fine. Yeah, like here. Maybe. Portal. Texture pack is not transparent, but it has transparency for the portal. It's just the texture pack doesn't have it. Okay, so now let's have a flow direction. Let's have a flow direction. Have a flow direction for the water. Let's have a flow direction. And it's when we place the water, the flow direction. Let me think about it. On placement. Let me think about it. Here flow direction is to the north. But wait a minute, what's the flow direction for the corners? Because here, this is like towards a corner flow direction. So there is like not only like north, south, east, west, but like for the corner direction as well, like a diagonal direction of the water. I don't have that kind of direction. Yeah, I don't have that kind of a direction. That kind of a flow direction. Interesting. Yeah. But we're getting there, let's just have this flow direction, just this one. Just this one. We'll not have the corners, we'll just have this one. And we'll make it go like a bit lower. Like here at this part it will be the highest, and here a bit lower, then a bit lower, lower. And it will be going just like this. So here, let me think about it. I'm not sure how to actually set it up. But we have everything we need. We have everything we need to do it. We have everything we need to do it. Where's the music? Yeah, we're missing a few parts. We're missing flow, like we have flow direction like property, we can set the heights of the corners. We just need to combine all of that. We just need to combine it. Yeah, let's do a summary. Let's do a summary. So I'll summarize what happened during this stream. During this stream, like chat decided and voted for us to add water, liquid physics, and we managed to spread the water, and we managed to like change each. We can change the height of each of the corners. And that's perfect for making the custom liquid mesh. Where is the Minecraft? Yeah, here. It's enough for setting the custom liquid mesh, because every corner has a different height level. We can set it up and use it, and the mesh actually handles it. And we also saw the water has a flow direction, and here I noticed, look at how here it goes just down, here just down, here down and down, but here it goes diagonally. And I added a property for the water to have if it's still water or flowing, and to have a flow direction. And we just need to set these blocks to be like going down, straight down, and these ones to have flow direction of diagonally. And using that information to set up each vertex height, and we'll have the custom water mesh, etc. And when we're like here at a corner, to like drop the water down and continue spreading it. Like we're pretty close. I think one more stream and we'll have water. But I limited at 3 hours so I don't burn out. But I think one more stream and we'll have the water done. I think we'll manage to do it. Yeah, but it was good progress. It was good progress, chat. Yeah, thank you guys for watching. Thank you for watching. And no, this is without the server. Thank you for watching, chat, and I'll see you tomorrow. Yeah, bye, chat.